Today we're going to talk about some terminology involving probability, and we'll talk specifically today about 5 specific probability rules you should know, love, and make your best friend. But the first thing that we're going to talk about here today is just some terminology that we use when dealing with probability. And I know some of this is going to be a little bit of review of what you were taught a little bit in Algebra 2. But the first term that comes up here is what we call our sample space. It is simply the set of all possible outcomes in a chance process. We use the letter S to represent it. So for instance, to give you a sample space, okay, I might say flip a fair coin. I'm looking at flipping a fair coin, S, I will let it equal all the outcomes when flipping a fair coin. What are those outcomes?
Heads or tails.
Heads or tails. So we like to use brackets. We'll just write heads, or H for heads and T for tails, and that's it. I might have something as simple as rolling a fair six-sided die. So guess what my sample space there is? 1, 2, 3, 4, 5, and 6. So it's all the outcomes that you can get when rolling a fair-sided die. So now, from a sample space, we'll talk about an event. As it says there, it's any outcome or set of outcomes of a chance process. Events are usually designated by capital letters A, B, or C. Sometimes, however, we might actually use a term or some word to help us remember, okay, an event. So for instance, I might say, event A is equal to rolling, rolling an odd number. So then A would be the set of what numbers? 1, 3, and 5. A probability model is our next definition. As it says there, is a description of the chance process and consists of 2 parts, a sample space S and the probability of each outcome. So when we talk about a probability model, sometimes we'll refer to it as not a model but a distribution or a distribution table. What can happen is what we'll have is 2 parts. We'll have the outcome X and the probability of X happening. So for instance, in flipping a fair coin, I have 2 outcomes. Either it's a heads or it's a tails. What's the probability of it being a heads if it's a fair coin?
Why did you say a fair six-sided die but not a fair coin? Oh, you did say fair. Sorry.
So,
Do you have to say fair though on everything?
well, I just say fair because I've taught this class so many times, and students will tell me, well, what if the coin is lopsided or is weighted one side, or what if the die is weighted so that 1 and 6 comes up more often than not? So I've just, in my habits, try to make sure I say that it's fair so that you know that the probabilities of each outcome are the same. So likewise, I could do a probability model or a distribution for the problem of rolling a fair die, where each outcome 1, 2, 3, 4, 5, 6. If it's fair, then I know I have a 1 in 6 probability on each of these. So, to give you an example where we practice seeing how some of these events are done and actually calculate out some probabilities, it says, in this example, it says, imagine rolling two fair six-sided dice, one that is red and one that is green. I know that it's at least shaded in your packet, but you can see how on mine here, you can actually see somewhat one of mine is red and one of mine is actually green. So below is a list of all 36 different outcomes. So on this, they actually show it to you. But you might remember back in your Algebra 2 days, you might have filled out a chart where you went 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, and then listed all of their actual outcomes this way. Whoops. So you can do it either way. What was nice was I could actually grab a picture of all 36 outcomes so that we could see it and wouldn't have to list them all out. But I just know that in not only our homework assignments here, but in general dealing with probability, we like to always deal with rolling a pair of dice. So, the first question here asks, if event A is equal to rolling a sum of 5, find P of A. What this P of A stands for is probability. So if you remember back when we were doing chapter 2, question, Asia?
So would your answer always be a fraction?
It could be a fraction or it could be a decimal. You can choose to do either one. As we saw, I think it was in 5.1 when we talked a little bit about probability and chance outcomes. It's always going to be a number between 0 and 1. But I will accept both. Okay? And since we don't do multiple choice questions in here, we don't have to worry about answers being fractions or decimals, because multiple choice questions, sometimes they'll give you decimals, sometimes they'll give you fractions. So, alright, so going back to here, that P of A is really representing what's the probability of event happening. So what's the probability that we roll a sum of 5? Well, how many 5s are up here? Okay, we have 4 and 1, 3 and 2, 2 and 3, 1 and 4. Did I miss any? No? Okay. So it is 4 out of how many? 36. That reduces to 1/9. What is 1/9 if you wanted it as a decimal? I think that's what, 0.1 repeating? I'll double check since my calculator's here. I have some other calculations here, but 1 divided by 9, okay, 0.1 repeating. If you want 1/9, I'm fine with that answer. If you put 0.1 repeating, I'm fine with that answer. The nice thing is we know that all probabilities should be a number between 0 and 1. Alright, so, are we okay with that question? Excellent. So B says, the next question says, if event B equals not rolling a sum of 5, find the probability of B. Well, what should the probability, which outcomes represent that? Okay, all of them that I did not circle. So I'm going to try to do that in a different color. So it's all of these outcomes and all of these fun outcomes. How many is that total? 32 out of 36, otherwise known as 8/9, or 0.1 repeat, or sorry, not 0.1, 0.8 repeating. I'm going to shrink this just a little bit here so that I can see the outcomes and still see the questions. Try to write a little bigger for us too. So what's true about the probability of A plus the probability of B? Well, let's look up here. 1/9 plus 8/9. What does it equal? 9/9 or 1. Okay? Why does that seem to make sense? Look at what you have circled. Okay, is it everything? Okay, so since it's the entire sample space, those two probabilities together should add up to 1. Alright, I'm going to switch colors here. Let's go to red. It says, event C is rolling a sum of a 6. Find the probability of C. So what's an outcome that gives me a sum of 6? 5 and 1. What else? Yeah, and? Okay. So it's just the flipping of them. So how many do we have there? 5. 5 out of 36. Next one. Find the probability of A or C. Well, A again is rolling a sum of 5 or rolling a sum of a 6. How many are there total? That's a 5 or a 6. 2, 4, 6, 8, 9. So that's 9 out of 36. I suppose which reduces down to 1/4. I apologize, I didn't do the decimal on the previous one. Do you guys want the decimal to the 5 out of 36? Yeah, okay. We'll just do that real quick. So let me pull out the calculator here. So 5 divided by 36. Okay, 0.13 with the 8 repeating. So, here's one thing that I want you to notice about A or C. Here I got it looking at the chart. What else do you notice that this probability is also equal to? What's the probability of A? 4 out of 36. What's the probability of C? 5 out of 36. So the probability of A or C could have been found by adding the probability of A and the probability of C together. So that does work if the next thing is true. What's the probability of A and C? What's the probability of rolling a 5 and a 6 at the same time? Can you roll the sum of a 5 and the sum of a 6 at the exact same time? How many times did it occur up here where you rolled the sum of a 5 or a 6?
Once.
Where?
You said or?
No, I'm sorry. I apologize. Roll the sum of a 5 and a 6.
Twice, excuse me, twice.
Where did the outcome add up to a 5 and add up to a 6?
I'll add up to a 5.
Okay? There's no outcomes. Okay? So in this case, that probability is 0. And that can happen where you're looking at, well, what's the probability that both outcomes are occurring at the same time? Sometimes you'll get results where it actually does happen. In this case, it doesn't. You can't roll the sum of a 5 and roll a sum of a 6 at the exact same time. Alright, so some of these examples that we just did here actually lead us and introduce us to some of our probability rules that you'll want to know, love, make your best friend. So all of these that we'll talk about, you want to know. Know this. Okay. First one we've actually already talked about. First rule of probability is that your answer is always between 0 and 1. Okay. So when you get an answer and somehow you have 1.7 better think to yourself, uh-oh, I did something wrong here. I must have done some sort of mathematical operation. Number 2, all possible outcomes together must have the probability of 1. Meaning, okay, the probability of your sample space equals 1. If you go back to the previous problem that we were doing, that's basically what we were demonstrating right here, okay, is rolling a 5 and not rolling a 5 was the entire sample space. It added up to 1. It included everything. Alright, the next one. If all outcomes in the sample space are equally likely, the probability event A can occur using the following formula. So your probability is simply taking the number of outcomes that you want over the total number in your sample space. So that's what we were actually calculating out. Probability of rolling a 5, 4 out of 36. Probability of rolling a 6, 5 out of 36. Now, number 4 is a very, very helpful tool, okay? And can help save you a lot of work when calculating out probabilities when you have to combine them. And this is otherwise known as what we call the complement, okay? The probability that an event does not occur. So I think of the word not as complement. Is 1 minus the probability of the event occurring. We call this the complement formula. So when I read this little statement here, it's like saying the probability of event A not happening. Or I think of it as the probability of not A is equal to 1 minus the probability of A. One of the things we could have done, if I go back a page here for a second, is when we look at this example right here, if event B not rolling the sum of a 5, this would be equal, okay, the probability of B would actually equal 1 minus the probability of A, because A was rolling the sum of a 5. So, getting this 32 out of 36 could have been done by going 1 minus 4 out of 36. The complement is nice because it can help you, like I said before, find solutions a little bit faster. And we'll see some more examples of this in just a second, too. Alright, the last two, actually the last rule, okay, and here's some terms that will pop up on occasion. If two events are what we call disjoint or mutually exclusive, what it means is they have no events whatsoever in common. Okay? The probability of the one, okay, or the other will just simply equal the sum of their individual probabilities. So another way of saying it is the probability of A or B will simply equal the probability of A plus the probability of B. Likewise, just to talk about it, if they are disjoint and mutually exclusive, the probability of A and B both occurring at the same time will always be 0. They can't have anything in common. Therefore, the word and means they both have to occur. And since they have nothing in common, that probability will be 0. So for instance, on the previous problem that we were doing, on the bottom, we saw that, hey, since A and C were disjoint or mutually exclusive events, we could just simply add those two probabilities together to get our answer. Alright, so let's take a look at, I can't believe I'm saying this, our last example. Then we'll let you start working on your CFU problems. So, in this example it says, randomly select a student who took the 2015 AP Stats exam and record the student's score. Here is the probability model. Okay? So 1, 2, 3, 4, and 5 are the possible scores you can get on an AP exam. And there's the probability distribution of those set scores. So, first of all, it says show that this is a legitimate probability model. Okay? This is actually going back in the notes. What two things must be true in order for it to be a legit probability model? Remember this? What must be true about all the probabilities?
We're gonna add up.
Okay, they got to add up to 1 is the second one. And the first one is the probabilities have to be between 0 and 1. So we know that all the probabilities are between 0 and 1. That's true, check, yes. And now does the sum equal 1? So let's go, 0.233 plus 0.183 plus 0.235 plus 0.224 plus 0.125. Does that actually equal 1? I'll slide my calculator way over here so I can at least see them all while I type them in. So 0.233 plus 0.183 plus 0.235 plus 0.224 plus 0.125. They equal 1. Woo! So sometimes what you could actually see is, and they'll do this in your textbook on some of your problems, is they'll give you a probability distribution table here, and they might omit, the probability for a score of 3, and they might ask you to find it. Okay, so what you could do is add up the scores and subtract from 1. Alright, so continuing on here, question B says, find the probability that a chosen student scored a 3 or better. So I want to know what's the probability of a 3 or better. So you can see how here, instead of using a letter to represent the event, if I can abbreviate that, I can also put that in the parentheses. But sometimes what they might actually say, event A is a score better than 3 or better. So sometimes they'll define it by a letter, sometimes you can just write it in. So to get this value, what do I have to do?
Add the last three.
Okay, so we need to add up 3, 4, and 5. So 0.235 plus 0.224 plus 0.125. Ooh. Is it 0.554? I did that in my head, so...
I think it's 5.
Oh, did I really screw up then? So I didn't carry something. Yeah, 0.584. Glad we checked. Find the probability that a chosen student scored 2 or worse. So really like saying 2 or, instead of saying worse, I'm going to say 2 or less. It's probably a quick, fast way to get those two. Add those up. So 0.233 plus 0.183. Do we dare check my math here? How'd I do there? 0.416? Phew!
If I wrote that 100%, would that be correct, or would it have to be in the form?
You should leave it as a decimal between 1 or 0 and 1, and here's basically why. It says to find the probability. If it says find the percent,
Okay, that makes
Yep.
sense.
so anytime I see find the probability, my number should be left as a number between 0 and 1. Good question. D says find the probability that start that again. Find the probability that a chosen student did not score a 4 on the exam. So, probability that it's not a 4. There's actually 2 ways I can do this. I'm going to show you the hopefully faster way. What word did I use in my statement here that might give you a clue on how to find this faster? I used the word not. When we talked about not, we talked about up here this rule number 4, the complement. The complement is equal to 1 minus the probability of that event happening. So this would be like saying 1 minus the probability of a 4. Well, do I have the probability of a 4 up there? Yeah, 0.224. So when I subtract that, 0.776. Now, I know that some of you are probably saying, well, Mr. Bartz, I could have gotten the answer by simply adding these 3 together and number 5 together. By all means, that's okay to do. But just to let you know, okay, we only had 5 outcomes. If we're talking about 25 outcomes or 30 outcomes listed, doing the complement will make your job a whole lot easier. And as we approach or as we start doing more and more different types of probabilities and certain types of probabilities, especially when we get into like geometric probabilities and binomial probabilities, the complement rule will be very, very helpful. All right, any questions with today's notes? All right, I will stop them here. All right, if you want to go ahead and take out your CF